Hi, I'm Dr. Laura Wilson. I'm the curator of paleontology at the Sternberg Museum of Natural History, and thanks for joining us for another episode of A New Way to Museum. So I've been doing a five-part series about my 5 favorite facts about dinosaurs, and this is going to be part 2 of 5, where my second favorite fact is how bird-hipped dinosaurs did not actually evolve into birds. If you missed fact 1, I talked a lot about how birds are dinosaurs, that all birds share a common ancestor, and that common ancestor was a dinosaur, the same way that cats and dogs share a common ancestor that was a mammal. We spent a lot of time talking about the dinosaur family tree, how we illustrated, how we determine relatedness amongst different types of species, and we spent a lot of time looking at pictures like this, which show these evolutionary relationships. So I'm actually going to follow up and talk a lot about these evolutionary relationships today, but really within the aspect of just the hip bones of dinosaurs, since that's one of the major ways that we divide different large groups of dinosaurs. So I'm actually going to go to a little less detailed version of the dinosaur family tree that really just has a couple of the big groups of dinosaurs. So we see the common ancestor to all dinosaurs kind of illustrated by this red dot labeled Dinosauria. That is pretty much the evolutionary origin of dinosaurs. Within dinosaurs, we then see 2 major groups. We have the Saurischian dinosaurs. And so Saurischia actually means lizard hips. So these are dinosaurs that are all grouped together because they have the same hip structure that looks like modern lizard hips. The Saurischians include a lot of familiar faces within the sauropods, so the long-necked dinosaurs like Brachiosaurus and Camarasaurus, and then also includes our theropod dinosaurs, which are both large and small, but largely meat-eating, with the familiar faces of Tyrannosaurus, Spinosaurus, and others. And this is in contrast to our ornithischian dinosaurs. So ornithischia means bird-hipped. And ornithischian dinosaurs share the hip morphology that is very similar to what modern bird hips look like. And our ornithischians include a lot of our plated dinosaurs like Stegosaurus and our horned dinosaurs like Triceratops, as well as armored dinosaurs like Ankylosaurs and the duckbills. So a lot of familiar faces within our ornithischians as well. And so it really all comes down to these 2 major divisions between our Saurischians and then our ornithischians is the hip structure, which, the name lizard hip versus bird hip might give it away. So the hip, and this includes our hips as humans, we're just a little bit different because our hip bones are all fused together. But dinosaurs have 3 distinct bones that make up their hips. They have the ilium, which is pictured in yellow, the pubis, which is pictured in red, and then the ischium, which is pictured in blue. So in both types of dinosaurs, the ilium is this big bone that attaches the hips and then the legs to the backbone or the vertebral column. So this is kind of the anchor of the hips and legs, and then also provides a lot of area for muscle attachment. The pubis in both types of dinosaurs is going to be on the headward side of the hip. It's one of the 2 bones that hangs down underneath the ilium, but it's on the head side. And so then you see the 3rd bone in blue, the ischium, is another bone that hangs down below the ilium, but it's on the tail side. And you can start seeing the differences between our Saurischians and ornithischians. With Saurischians, the pubis points more towards the head. And then in ornithischians, the pubis actually lies flat against the ischium and points towards the tail. So this Saurischian is a very lizard-like articulation or lizard-like putting together of the bones, and then the ornithischian look more like the bird hips in our modern-day birds. But we need to think about this not in terms of just what one animal hips look like in one type of animal in one point in time, but we need to start thinking about this in terms of change through time or evolution. So how different animals change through time, and then how their different body structures change through time as well. And so we can actually plot these hip bones on this dinosaur family tree, or this phylogenetic tree, cladogram, whatever term you want to use. And we start seeing our major divisions. So all ornithischians that share this bird-like hip structure, and we see some of our familiar faces, our horned dinosaurs, our duck-billed dinosaurs, on one side of the family tree. And then we have all of our saurischians with our meat-eating dinosaurs, our T-Rexes, our velociraptors on the saurischian side of the tree. But to really understand the idea of bird-hipped dinosaurs not evolving into birds, we need to actually look at a bigger family tree that includes what dinosaurs are still alive today. And as we talked about in part one, the dinosaurs that are still alive today are birds. So I showed this a lot in the last segment. I showed this at the beginning of this segment, and this is again a more detailed dinosaur family tree, really focusing on the saurischian side of the tree. And we can look at a bunch of big points within the evolutionary history of dinosaurs. At the very top, we have the common ancestor of all dinosaurs. So we have our ornithischians, and then everything else is a saurischian. So then all saurischians are kind of linked to this point, where we would have our sauropods, sauropodomorphs, long-necked dinosaurs, and then everything else on this is a theropod dinosaur. So again, we see familiar faces: Allosaurus, Tyrannosaurus, Dromaeosaurs, which include things like Velociraptor. And then we get down to the bottom of the tree, and this point is actually what defines birds. We have our fossil birds and then our living birds. So we talk about birds being theropod dinosaurs. Theropods are saurischians, and saurischians are one of our big groups of dinosaurs. So birds are these saurischian dinosaurs that, as the name infers, we have a lizard-hipped hip structure. But let's look at this in terms of change through time. So I just have a couple of sketches up here of different hip structures. So we see those three bones. In this case, the pubis is actually going to be on the right side of your screen, so a little bit opposite of what we showed in previous slides. And what we're seeing here is we have our alligator, which has a very lizard-like reptilian triangular hip structure with your ilium on top, your pubis on the right, and then your ischium on the left. And then we get to some of our basal dinosaurs, and then we get within our theropods within Tyrannosaurus rex. And kind of after the point of Tyrannosaurus rex, we really start seeing that pubis swing back towards the tail. So it's not oriented or pointing so much towards the head as it is the tail, as we get further within this theropod dinosaur lineage. And then we get all the way to the right to things like Archaeopteryx, which a lot of paleontologists consider to be the first fossil bird. So by the time we get to fossil birds, we actually really see that pubis, that headward hip bone, really starting to point more towards the tail. And we can look at this in a little bit more detail as well, where we have our not a dinosaur hip structure, very lizard-like, and even early dinosaurs, including our early Saurischian dinosaurs, have this hip structure. As we get closer to birds within the Saurischian, within the theropod lineage, we really start seeing significant changes within the hip structure, specifically what that pubis bone is doing. By the time we get to almost a birds, is vertical. Our early birds, so this is something like Archaeopteryx, is actually Jehornis, start swinging towards the tail. And then we get to our fossil birds, and we're really seeing that bird-hipped hip structure, which we then see in our living birds. The blue box is the ostrich, and then the last image is a chicken, just for reference. So we can really see these and take them into the evolutionary lineage to look at these changes from early dinosaurs to birds, near birds, to fossil birds, and then to true living birds. And so we can start seeing the change in hip structure within our Saurischian, so within our lizard-hipped dinosaurs, towards that bird hip structure. So this is just one example of how before we really understood evolution and put evolution into our paleontological research, we called them as we called things as we saw them. And so we saw a lot of similar dinosaurs with similar hip structure, and that hip structure was similar to what we see in our modern lizards. And it's really only been in, the last 150 years since Charles Darwin, and we've started applying evolutionary theory to animals and animals changing through time. So really all organisms, not just animals changing through time. We can really see that we might have a couple of misnomers out there, but we really have to take the whole picture of, yes, what a specific type of organism looks like, but then also how that organism fits into a family tree, and then how individual characteristics change through time and through family trees. So thanks for joining us for my fun fact number 2, that bird-hipped dinosaurs did not evolve into birds. It was actually the lizard-hipped dinosaurs that evolved into birds. So if you like this video, hit the like button. Please leave me a comment if you have any questions. I'll be happy to provide any sources for additional information. And don't forget to subscribe to our channel if you would like more content like this. So please join us next time where I will cover fun fact 3.
Thanks for joining us in A New Way to Museum with the Sternberg Museum of Natural History. If you enjoyed this video, like it and subscribe to our channel. Hit the bell for notifications when we release a new video. Support us on Patreon for early access and exclusive content. You can also follow us on all our social media. Links are found in the description. Thanks for watching, and follow your curiosity to new discoveries.